All right, hey Honors Chemistry, I just wanted to do some of the problems that you will find in your homework tonight. So, in the first part, I just randomly chose two of them to see that we're getting the ball rolling. So, for example, if I wanted to write the formula for something that involves calcium and ClO3 minus, well, ClO3 is the chlorate ion, and Ca is calcium. And calcium, is that a transition metal? Nope. So I know it's not going to need a Roman numeral. It only has one charge, right? I'm just putting it here on the side. I still want to name it calcium chlorate. In your homework, you don't have to name the top ones, but it's nice for practice. If I want to figure out how many of each ion I need, the least common multiple between 2 and 1 is 2. So I'm going to need one of these, and I'm going to need two of these. So Ca2 plus, ClO3 minus 1 twice. This is positive 2. This is negative 2. If I want to write that formula that has one Ca and two ClO3s, I'm going to put parentheses like that. So I'm going to have two ClO3s. And the way I do that is parentheses with a 2 on the outside. Okay, let me do the next one here. This is the ammonium ion, and this is phosphide ion. If I were to name that in the compound, it'd be ammonium phosphide. And are there any transition metals here? No. Now, ammonium is positive 1 charge, phosphide is negative 3. What's a common multiple, or least common multiple, between 1 and 3? Well, it's 3. So phosphide is already at 3, so that means I only need one of it. How can I get ammonium to be at 3? Well, I'm going to need 3 ammoniums. And 1 phosphide ion. Positive 1, positive 1, positive 1. That adds up to positive 3. This is negative 3. That equals 0. How do I write a compound that has 3 ammoniums and 1 phosphide ion? Well, oh boy. Okay. Well, the way that I do that is NH4. If I need 3 of them, it's got to go in parentheses and then a P. So the parentheses and the polyatomic ion doesn't always have to be negative, and it doesn't always have to be second like this one. Ammonium is one of our cation ions. That's a polyatomic ion. Polyatomic cation. Okay? Now, I will show you the trick again with the crisscross method quickly before I move on to naming. Oops, 3 minus. If I crisscross, a 1's going to go over by the P, and a 3 is going to go next to the NH4. Right? And it's going to be P1. And remember, I need to put those parentheses on because if I needed more than one polyatomic ion, I need parentheses. And then, of course, I don't need to write 1 as a subscript. So that just becomes NH43P. So that's just showing you like the shortcut of the crisscross method. Again, if you're comfortable and like the crisscross method, use it. If you don't, I love the least common multiple way. All right, now let's try and name these things. Now, these, I'm going to tell you right now, are transition metals. If you look on the periodic table, they are found smack dab in the middle. Mo is right here, it's molybdenum, and Ru is ruthenium. They are transition metals. So I'm going to already set us up and put parentheses. Parentheses, parentheses, because that's going to be for a Roman numeral. If I want to name them first, I mean O is oxide. Doesn't matter how many there are. And Mo, we said, was molybdenum. And I'm going to put the parentheses because I'm going to have to figure out the charge. For this one, this is Ru, that's ruthenium. And NO32, well, if I look at a polyatomic ion table, NO3 is the nitrate ion, and it's a -1 charge. So nitrate. Okay? So now I want to figure out the charge, and I'm going to do it like I did in a previous video. I have 3 oxides here. I have O2 minus, O2 minus, O2 minus. Those equal -6. How many molybdenums do I have? 2. And what do those 2 molybdenums need to equal? Well, if this is -6 and I want the sum of the charges to equal 0, this must be +6. And that +6 is distributed evenly amongst the 2 molybdenums. That must mean that if each molybdenum have the same charge, and they do, they must be +3, because +3 and +3 will give me +6. And so I put Roman numeral 3 in the middle there. If I'm going to do the ruthenium, I know the nitrate ion is NO3 minus 1. And there's 2 of them. And there's only 1 ruthenium. If there's 2 NO3 ions, that's -2. What must ruthenium be to add to -2 to give me 0? Well, it must be +2. And that means I put Roman numeral 2 here. Okay? And then finally, I did get a couple of questions on this one. We have to be careful. And this is all in your homework, so you're going to have to find out where these are. And you may have this in a pop quiz. Now, these 2 are polyatomic ions. Are there any transition metals here? Any transition metals in this last one? No. Are there any metals at all? No metals. At all. We'll talk about what happens when I have a compound with no metals later. But I know that these have ions because these are both polyatomic ions. And there's a lot of symbols in here. Now, the way I name NH4, and we did it up here, the way I name NH4 is ammonium. And it looks like that there's 3 of them. Okay? And the way I name PO4 is phosphate. And it looks like there's 1 of them. And it has a -3 charge. So if I look on here, ammonium is NH4. I don't write the word ion. NH4 is ammonium. PO4, which is over here, is the phosphate ion. And I don't say or write the word ion. It's just phosphate. So the way that I name NH4, 3PO4, doesn't matter if there's 3 of them, it's going to be ammonium phosphate. Okay? So this was just doing some selected problems from your mixed practice. Hopefully this helped you kind of get some of the answers to your homework and check your work. And you will need to understand this for a future test or quiz. Hopefully this was helpful.